Hello there and welcome. Look, if you've ever had that sinking feeling, worrying about losing all your photos, your work files, your entire digital life, well, you are in exactly the right place. Today, we're going to pull back the curtain on a really powerful technology that's designed to stop that nightmare from ever happening. It's called RAID, and we're about to demystify it. Let's jump in. So just think about this for a second. Everything you've created, every memory you've saved, all sitting on one single spinning disk. It's kind of a scary thought, isn't it? One weird noise, one sudden click, and poof, it could all just be gone. That single point of failure is the exact problem that RAID was created to solve. It's all about getting you out of that super risky situation and into a much safer one. And here's the solution: RAID. It stands for Redundant Array of Inexpensive Disks. Yeah, inexpensive is right in the name. The whole idea, which actually came out of a university paper way back in 1987, is just brilliantly simple. Instead of putting all your trust in one single drive, why not get a whole team of drives to work together? This teamwork can give you a major speed boost, rock-solid protection for your data, or, a really smart mix of both. Okay, so how does this whole team of drives thing actually work? Well, it really all boils down to just three core concepts. Seriously, once you get these three ideas, you'll pretty much understand every type of RAID array out there. First up, we've got striping. The easiest way to think about this is to imagine you're writing a really long sentence, but you're using two pens at the same time. You write the first half with one pen and the second half with the other. Since you're writing to multiple drives at once, you get the job done way, way faster. Striping is all about one thing, and that's pure, raw speed. Next, we have mirroring. And this one is, well, it's exactly what it sounds like. Every single piece of data you write gets instantly duplicated onto a second drive. It's like making a perfect photocopy in real time. So if one of your drives decides to give up the ghost, no big deal. The identical copy is totally safe and sound on the other drive. This right here is the heart of data redundancy. And finally, we get to the really clever one: parity. Now this feels a little bit like magic, but I promise you it's just some simple math. So imagine the system takes two chunks of your data, right? Let's say the number 5 from drive A and the number 3 from drive B. It does a quick calculation, 5 plus 3 is 8, and it stores that parity number, 8, on a totally separate drive. Now, if drive B fails and that number 3 is lost, the system can just look at drive A and the parity drive and figure it out. It asks 5 plus what equals 8? The answer is 3. It's an incredibly smart and efficient way to build a safety net for your data without having to make a full copy of everything. All right, so now let's see how these building blocks, striping, mirroring, and parity, get mixed and matched to create the standard RAID levels that you hear about all the time. Just think of them as different recipes, each with its own unique blend of speed, storage space, and data protection. Okay, this right here is basically your cheat sheet for all things RAID, so let's walk through it. First up, RAID 0. This is pure striping, all about speed. You get to use 100% of your disk space, which is awesome for things like video editing. But, and this is a huge but, look at the fault tolerance: 0. If a single drive fails, you lose everything. Next, RAID 1. This is pure mirroring. Now, you only get to use half of your total space, but you can lose an entire disk and your data is perfectly fine. This is great for your operating system or really critical files. Okay, now for the balanced options. RAID 5 uses that clever parity trick. You need at least 3 disks, and you lose the space of one of them for that safety net. It's a fantastic middle-of-the-road choice for file servers. RAID 6 just takes that a step further. It uses 2 parity calculations, which means you can actually lose 2 drives and still be okay. This is so important for big arrays where you're worried about another drive failing while you're fixing the first one. And finally, RAID 10. This is the best of both worlds. It combines the speed of striping with the security of mirroring. It's blazing fast and super redundant, perfect for databases, but it's also pricey since you lose half your capacity. But, it's not all smooth sailing. When you use RAID, especially those parity-based levels, there are some really important trade-offs and even some potential dangers that you absolutely have to know about. And that brings us to a super important idea called the write penalty. So for every single piece of data you want to write to a RAID 5 or RAID 6 array, the system has to do a little dance. It has to first read the old data that's already there, read the old parity calculation, then it can write your new data, and finally it has to calculate and write the brand new parity. All that extra work, read, write, means that writing data to these arrays can be a lot slower than you might think. And this leads us to probably the most stressful time for anyone who owns a RAID array: the rebuild. The moment a drive dies, your array is vulnerable, it's running in what's called a degraded state. As it's working like crazy to rebuild all that lost data onto a new drive, it's putting a ton of stress on all the other drives. And if those drives are all about the same age, the chance of another one failing goes up. If a second drive dies during that rebuild process, which can take hours, sometimes even days, it's game over. You lose everything. This is exactly why RAID 6, with its ability to survive 2 drive failures, is so popular for large, important arrays. So, what's it actually like to restore an array? Well, here's the basic playbook. First, you've got to power down the system and physically swap out that dead drive for a new one. Then you power it back on, get into your RAID controller software, and kick off the rebuild process. And then you wait and you hope. It can be a real test of your patience, and it's a very powerful reminder of why having that redundancy is so critical in the first place. Okay, so now that you get the how and the why of RAID, the next huge question is how do you actually set it up? And this brings us to a really fundamental choice. Are you going to use hardware RAID or software RAID? So with hardware RAID, you've got a dedicated card that you plug into your computer. It has its own processor just for managing the drives. This means you get better performance and it doesn't slow down your main computer. But here's the killer feature. These cards usually have a battery backup unit, or a BBU. This little battery protects any data that's waiting to be written if the power suddenly goes out, which prevents your files from getting corrupted. On the other hand, software RAID is usually free. It's built right into your operating system. But it uses your main computer's CPU to do all the work, and it has absolutely no protection if you lose power in the middle of writing a file. Now, the great news is that software RAID is everywhere. It's super accessible. I mean, whether you're on Windows with its storage spaces, a Mac using disk utility, or a Linux machine, the tools to create a RAID array are probably already on your computer, just waiting for you to use them. And we should also give a quick shout out to proprietary solutions. Companies like Synology have come up with their own really flexible systems, like Synology Hybrid RAID, or SHR. These are honestly fantastic for home users because they let you do things that are tricky with standard RAID, like mixing and matching drives of different sizes and easily adding new drives to make your storage pool bigger. So with all these different levels and options, how in the world do you choose the right setup for what you need? Well, it really just comes down to asking yourself a few key questions. You really just need to weigh these 4 things. First, what's your budget? Second, how important is your data? I mean, really, can you afford to lose any of it, even for a little while? Third, how much actual storage space do you need after you account for the drives used for protection? And finally, what kind of performance are you looking for? Answering those questions, honestly, is going to point you right to the perfect RAID level for you. Let's get practical. For a typical home user who's maybe running a media server or just wants to back up family photos, a simple 2-drive RAID 1 is a fantastic, super straightforward way to protect those critical files. If you've got a massive movie or music library and you need more space, something like RAID 5 or that flexible SHR from Synology gives you a great balance of big capacity and solid protection. Now, for a small business, the stakes are obviously a lot higher. That data is your livelihood. In this case, RAID 6 is an excellent choice because it can survive 2 drive failures, which gives you a huge amount of peace of mind. But if performance is more important, maybe for a server that's constantly being read from and written to, then RAID 10 is going to give you that awesome combination of speed and safety. And then you have those situations where performance is everything, like a really busy database or a high-traffic website. When speed is the absolute #1 priority, RAID 10 is almost always the king. It completely dodges that parity write penalty we talked about, which means it delivers amazing write speeds while still giving you fantastic protection. I love this quote because it just gets to the absolute heart of the matter. Having a RAID array or any other kind of backup is totally useless if you can't actually get your data back when something goes wrong. The entire point of all this tech is to make sure you can have a successful restore. So in the end, RAID is an incredibly powerful tool, but it's so important to remember what it is, and maybe more importantly, what it isn't. RAID is like a seatbelt. It protects you from a sudden, catastrophic hardware failure. But it is not a parachute. It's not going to save you if you accidentally delete a file, and it won't save you from viruses or ransomware. It's just one crucial piece of a bigger data protection strategy. Your data really is your story. And now you've got the knowledge to protect its next chapter.